Alright, today's job, I've got a Trane air-cooled chiller. It seems to be not putting out cold enough water. Check it out, see what's going on. This is a CGAM100. Entering water, leaving water is 48.6, and we do have an alarm present. So, alright, let's dig into this and see what's up. Alright, so alarm, we've got circuit 2 is stopped, circuit 1 running limited, suction pressure limit. Compressor A is running. Let's go back to 2. Circuit 2, diagnostic shutdown. Alarm. Shut down yesterday. Suction temperature too high. Alright, let's go back. Operator, circuit 2. Suction temperature says it is 81. Saturated is 51. Circuit 1 is running. Got 52 suction temp, 39 saturated. So let's pull some covers off and take a look at that sensor. Alright, so I got my gauges hooked up here to circuit 2. And our standing pressure, we got 145 and roughly about 235, 240 on the high side. Our saturated temperature, it works out to be about 51-ish. And this was saying circuit 1 saturated suction temp was 51.6. Our suction temperature was 85.5, so let's measure that. Here's our sensor right here. We'll get right on that thing. Okay. 60 degrees. So, we do have a bad sensor, looks like. We'll swap that out. And see if that makes a difference. Alright, so we got our unit view up here. Let's go into binding view. Yes, we want to stop the chiller. Might as well. Make it quieter here. Now we can hear. Alright, we'll let this pop up and take it from there. Alright, suction temperature, circuit 2. We're going to... Oh crap. Well, that was water flow. Wrong one. Alright, I guess we're going to have to bind that sucker. Evaporator, water flow, switch, phase up. Not that. I swore I had it up there, but... Okay. Let's bind this new sensor. Alright, so since I hit the wrong button to begin with, evaporator, water flow, switch, and phase protection inputs became unbound, so you find those up here on diagram, and it's located 1A17, 1A17. So let's try to bind that, and we'll come back down here, bind it. Are we selected? Almost. There's our switch. The light is on. Please bind. Success. Alright, so now we can get back to binding our suction temperature sensor. Let's grab that new one. Alright, so we're back here on circuit 2. This is our suction temp sensor. Get that out. We can disconnect this. Put you guys up here. Alright, we got our new sensor here. Plugged in. Put some lube on it. Let's shove that back in the hole. Get you started. Make sure it's up in there good. Alright, so now this one we're going to have to bind since it's a new sensor. So let's come back over here. I've already asked it to bind suction temperature sensor. Is it selected? So let's go back and select. Let's see. I can let you see. Let's do it like that. Alright, so we'll light her up. Green light's on. And let's go back and bind. Yes, we are. It bound. Let's go back to our unit view. We've got our unit view back up here. Our, let's see, circuit 2, suction saturated temp was 65, suction temperature 64, which is probably about right because the chiller's been stopped, and we were about 60 degrees before. Let's get in there. 64.4. All right, we're reading more accurate now. I think we can go ahead and restart this chiller and see what happens. Circuit 2 and reading on the CH530. Temperatures look better. Should stay online. Our water temperature got up to 64.7 entering. And this is the only chiller right now for the building. They have construction going on. There is another chiller over here. It's a Daikin. Know nothing about that one yet, and yeah, so that's what we're dealing with. Alright, let this run a little bit and come back to it and see if that other issue was there for the other circuit. Alright, so just circuit 2 is running right now. I've got suction pressure 137.8, suction saturation 48, and suction temperature is 60. So let's go, EXP is 32%. Let's see if that lines up. Yeah, suction pressure is about 137. Or, didn't check the liquid, but other circuit just came on. They are 61 degrees, 60 degrees suction temperature. 60 degrees suction temperature, so we're reading correctly now. Let's see, go back and check condenser. Circuit 2 discharge is 358. turbine. I guess I could connect to the discharge. Alright, so when it connected to the discharge, we are about 340. And 354, 353. We'll see if this is going to settle out. Might need to do a pressure transducer. Circuit 1 has started, and our system, both are running, entering water temp 57, leaving 51, demanding 100%. The alarm stay away now because we gotta get suction temperature reading and get that sensor. Alright, so that takes care of that problem. Alright, things were working okay until we started getting loaded up, and my discharge pressure has shot up to 432. Still reading low, but I went up top here to check the fan motors. I got 3 out of 4 running here. This one, it's not even plugged in. So, I don't know what the heck happened here. I see some broken pieces down in there, but this is also rubbing. I'm gonna have to shut her down again and find out why. Alright, so I got the control panel open here. These are all the contactors for the fan motors. And this top one is not pulled in. So I'm thinking these are circuit 2. And checking across the coil, I don't have 120 volts. Let's see this one down here across the coil. I do have 120 volts. Alright, so the overload is here, and we have normally closed between 95 and 96. So I shouldn't get a reading there. I am getting 120 volts. So this overload is tripped. Reset that. We have the plug is obviously disconnected up there, and just verify it's not moved. Yeah, it's trying to. It won't move now. All right, let's go down. Reset that. It engage. We now have 120 volts on our coil, and our overload is now closed, so we should have voltage at that plug. I'll do my best to get the voltage on here. See if that screw is good enough. Yep. 120. 118. 119. So 1 and 3, we have 204. 1 and 2, we got 206. And 203. Or 2 and 3, we got 206. So we have power. We'll just shut this thing down, double check that motor, and hopefully it's just came unplugged, but something happened in there. I don't know if trees fell in there or some other debris. I saw some stuff in the bottom, but the blade looks like it's intact. I didn't shut that. Nothing. Alright, so voltage is off. We can check this motor. Let's see if it's got any shorts or anything. Let's just do that. Alright, got 3.7, 3.5, 3.6. Let's check 1 and 2 again. 3.5, 1 and 3, we got 3.5, 2 and 3, 3.5. So they're all equal. Nothing to ground. I think we just came unplugged. Back. This one plugs in better than, yeah, that's how they should plug in. Alright, so here's what I found out. I spoke to some other mechanics who had been out here previously. They said that they had ordered a new motor, blade, and the shroud because they said it was, rubbing. So I found the bolts were loose on the mounts at the bottom. Tightened it up. I saw a few little dings here and there. So kind of straightened them out with my wrench. And I'm going to throw this blade on there and see how it's not rubbing like that. And the motor tested out good. I don't know why. But we'll find out. We're going to put some power to it here in a minute. I'm not afraid. This could just be in case somebody else had been working here. They said they left the motor disconnected, but that thing definitely had tripped. I don't know if they tried resetting the starter or not, but we'll see. A little rub. We'll put the shroud on, crank it back up, let's see what blows up or not. Alright, so I got the power back on, that shroud is back on. I'm just going to bump this fan starter. It's not set to come on, so hey, let's see what happens. It's either going to blow or it's not. She's spinning. Let's check our amp draw on that thing. Let's see. Sound the best, but it's working. Let's go check it. Yeah, we definitely had the right one. So 6 amps. Let's verify that amp draw. It's just going to be noisy, but work. Good air conditioning back into the building. They do have a motor on order. Let's see. Our motors are 6.2 amps. 8 of them. think we were right there. Let's check the other leg. Let me just jump back up there, make sure I got everything not rubbing as much as possible, and we'll fire this thing back up. Shut the power off. Alright, so what I did was got some washers and just put them in the top mounts there to kind of kick the motor back this way, because it seemed like it was leaning this direction and hitting that shroud. So now we're free, nothing is hitting. The motor feels good. Don't feel like it's bad bearings or anything. So I'm gonna put this back together, get it going, because it's getting hot in that building. Alright, I got the chiller started back up here. Both circuits are running. 56 entering, 48 leaving. Still a little high. Circuit 2 discharge pressure is 412. We are just a hair under 400, 398. So probably going to end up swapping out that transducer for that. Circuit 1 discharge is 403 over there. I'm sure these coils probably need to be cleaned since they've been doing a lot of construction around here. But it's also hot in school. Monitor this for a little bit and revisit this when temperatures come back down. Alright, thanks for watching. This was a Trane air-cooled, I believe it's 100-ton CGAM100. It was a suction temperature sensor was bad on circuit 2. Replaced that, started back up, and found that issue with the condenser fan motor up there, which ended up being somebody else that had been here working on it, and they didn't tag it. So it is working now, but they're going to go ahead and replace the motor and shroud whenever they get it. But that's it. Alright, thanks for watching. Let's go up here and see these motors one more time. It's a little noisy still. They're all going. They got air for now. Catch you on the next video. Alright, thanks for watching. Alright, you didn't think I was going to leave until the water temperature was down, so there you go. 44 leaving, 51 entering, running 100%.